The next step in our 16S MySeq data analysis workflow after combining the paired trees to contigs is to screen the sequences for various things such as length, ambiguous spaces, and homopolymers. So the Chipster tool screen sequences for several criteria is based on the Motor tool screen seeks. And it filters sequences for length, ambiguous spaces, and homopolymers. You have two options. So you can either set the minimum and maximum sequence length manually when filtering for length, or you can select optimize and just tell what percentage of sequences you would like to keep. As an input file, you need to give the contigs in the FASTA file and the groups file. As output, you will get the screened or filtered sequences, updated groups file, and also a summary file. So let's have a look at the parameters of this tool. It's important to note that the same tool is actually used before and after aligning the sequences to the reference, so some parameters actually apply only to this stage. As we can see here, we can filter based on the minimum length, maximum length, either entering those values directly or optimizing, selecting what we want to optimize for and then setting the percentage. And we can also set the maximum number of ambiguous spaces and the maximum homopolymer length. Now there are also these two other parameters, and these are used only once the sequence have been aligned to the reference. So we'll look at those later. Once the sequences have been screened, we want to remove identical sequences. So why would we want to do that? Well, many of the sequences are absolutely identical, and we are going to align the sequences later on to the reference. So it would be pointless to do the same thing over and over again. It would be computationally wasteful. So we will remove those identical sequences and only keep one representative for each of those groups in a FASTA file. And at the same time, we need to keep track of how many sequences and in what sample that representative represents. And we store this information in a Countable file. If you were doing this in Motor on command line, you could also use a list of the names of the represented sequences. So that would be a names file, but these tend to become very large as the sequence names are very long and there are thousands of them. So we prefer to use the Countable file. The Chipster tool remove identical sequences is based on the Motor tool's unique seeks and count seeks. And as output, you get your unique sequences and this count table, which we are going to have a look at in a minute, and a summary file. So the count table file looks like this. So here, each row has a sequence name. So this is the name of the representative sequence, and then a number. So this particular sequence represents this many sequences in total. And here you can see how these sequences are distributed between the different samples. So as columns, here we have the different samples. The summary file we had a look at already, but now you can see that there is actually a new row which has appeared here telling that, well, in total we have this many sequences, but out of these many are unique.